Hello everyone, myself Chintan Patel. My student ID is UPO5058. Today I will be presenting on a crucial aspect of modern IT infrastructure, secure network implementation and management. As organizations grow more reliant on digital systems, the need to protect our networks from internal and external threats become more critical than ever. In this presentation, we will explore the key principle of building a secure network, how to effectively manage it, and best practices that help ensure confidentiality, integrity, and availability of data across the organization. We will also look at current trends and technologies shaping the future of network security. As our presentation on task 3, where we demonstrate how we secured and configured the finance department network using Cisco Packet Tracer. Over the next few minutes, we will cover our approach to hardening the router and switches, implementing best practices such as SSH, ACLs, and port security, and validating our network through simulation. Each group member played a key role in design, configuration, testing, and documentation, and we are excited to share our result with you today. Let's begin by revisiting the cyber threats that informed our security measures. In section 1, we conducted a threat analysis and identified several risks that guided our network hardening efforts. First, we noted unauthorized access attempts via unsecured protocol like Telnet, which could expose credential in clear text. Second, MAC address spoofing and rough devices on an open switch ports posed the threat of unauthorized network entry. We understand now about MAC spoofing. So one of major concern is MAC spoofing. In this attack, a malicious actor changes their device's MAC address to impersonate another device on the network. This can be used to bypass access control or to intercept data intended for someone else. MAC flooding is another attack, often targeting network switches. The attacker sends a flood of packets with fake source MAC addresses, which overload the switch's memory. As a result, the switch enters a fail open mode, sending all traffic to all ports, which the attacker can then snipe and analyze. We understand about the DSCP spoofing could enable attackers to distribute malicious network settings to clients. Finally, insider misconfigurations and lack of encryption of management interfaces increased our attack surface. Recognize these vulnerabilities helps us prioritize our SSH, port security, and ACL implementation.
Hello, my name is Kishan Patel and my student ID is AZZ5729. Here we begin with the draft security policy focused on verifying IT communications, but we quickly realize more technical control were needed. In peer review sessions, colleagues suggested replacing Telnet with SSH for encrypted remote management and strengthening password complexity. We also added port security measures on access ports to prevent authorized services from connecting. Feedback promoted us to complexity define ACR rule to segment and finance operations traffic. After comparing these suggestions, our refrigeration policy now addresses both users' behavior and device configurations, ensuring a comprehensive approach to network security. In the number 5, risk management and incident response highlights, our risk management plan identify key assets such as the finance database server and the domain controller as a high priority. Guiding our protective measures, we apply ACLs on router interfaces to restrict inter-department traffic and disable unused ports and interface to reduce the attack surface. For incident response, we identify clear roles. IT support handle containment and the forensics. The finance management communicates with stakeholders and the staff report anomalies immediately. We also establish regular review timelines, quarterly review and the post-initial assessment. to ensure control remain effective and updated. This plan supports both prevention and the rapid recovery from incidents. From in the number 6 slide, network review in packet tracer topology. In this slide, show our packet tracer network design, which include the PCB router connect to 4 switches. Finance device occupy VLAN and 20 on the left side and the operation device use VLAN and 20 on the right. Fast Ethernet interface from the router connect directly to each core switches and the switches are chained via trunk links on the port FA0.24. The router serial interface link to Stimulate Cloud for the internet access. Each well and the link has been correctly cognized to enforce segmentation and the secure device management. This topology underpins our subsequent cognitions and the testing steps. Thank you.
Hello, my name is Patel yes, and my student ID is AZZ37289, and today I talk about slide 7, 8 and 9. So let's start. Slide 7, Router Configuration Overview, PCB Router. Here are the key configuration on PCB router. We set the host name to PCB router and the domain name to pcb.local for certified consistency. Console access is protected by the secret class and user admin with a strong password. We generated RAS keys for SSH version 2 and restricted line. Login local and transport input only. Interfaces were assigned and respectively with IP helper address. Relay, we also created 10 and 20 permitted only fiance and operations service. Slide 8. All 4 switches share a standardized security configuration. We set the host name, enabled secret classes, and console password. Each switch we configured switch port mode access. Switch port security limited to 1 sticky MAC and violation restrict. Were shut down to prevent unauthorized connection on configuration truck mode interface. These measures protect against MAC spoofing and devices while ensuring proper VLAN segments across the finance and operation networks. Slide 9. To confirm our settings, we run several verification commands in packet tracer. So IP interface brief. Shows all router interfaces up with correct IPs on the router. Shows access leads. Demonstrates ACL 10 and 20 filtering correctly. Switches responded by show port security by displaying one learned sticky MAC per interfaces and show interfaces truck. Confirms truck links active. We also tested connectivity. Finance PC could reach but not vice versa of operations PCs. This test prove our configuration informs the intended security policies. Today we talk about evidence of working configuration, testing and verification. To confirm our setting, we can run several verification commands in packet tracer. So IP address brief shows our router interfaces with correct IPs. On the router, so access list demonstrates ACL 10 and 20 filtering correctly. Switches responded by to show port list security by displaying one red sticky MAC per interface. And so interface is trunk. Confirms trunk links active. We also tested connectivity finance PCs could reach, but not to vice versa for operations PCs. These states prove our configuration enforces the intended by security policies.
Hey guys, my name is Chirag Sifara. and my student ID number is HI6041, and today I am going to our presentation for slide number 10, 11 and 12. And first off, I am going to slide number 10, group collaboration and contribution. Our team coordinated through weekly Google Meet and session and used GitHub to version control. Our configuration script, we did the route, configuration and ACL design, and handle switch security and VLAN design, and also develop the risk and plan incident. Response documentation, this structure allow us to integrate, peer review seamlessly and resolve configuration issue swift. And slide number 11, the learn to listen. We had a number of difficulties while working on this project. We taught us important lessons. It took some time to probably produce RSA key page when configures SSH, which taught us to be patient and to plan ahead for procedure. For them until we probably configure trunk ports between switches. Our early WAN configuration caused connection problem, highlighting the need of proper lane tagging and tracking in the last order. Order to listen, we also understood how circular it was set safe default on all devices, such as turning off unneeded service and ports last but not least. Excellent teamwork unable to effective throwing hooting proving that successful. Network security implementation dependent on clear communication and cooperative problem solving. And now I'm going to slide number 12. Conclusion, summary and reflection. In completed task, we gained practical insight into network, some semantic security management, and resource testing. We learned to how SSH, ACLs, and port security collectively reduce the risk of common attack like unauthorized access and supporting. Our approach highlighted the importance of regular policy review and accident. Simulants to maintain relies collaboration, tool and peer feedback were invaluable in both of our policy and technical configuration. Overall, this exercise has significantly strengthened our understanding of real world network security practices. Thank you guys.